So this is basically the video of showing how to implement the results of MFiX into Paraview, how to view the particles that you have generated, and with all their variables like temperature, contact force, for example, and etc. And also the information relevant to the cell simulation, like for example the pressure and the velocity of each cell. For example, I'll go here to open the project that I've already done. Open project, browse, and we will be going to the case folder. For me it's here, and we will go to the .mfix file. Okay. We will go to modeler, and then we will go to exactly output, and then we have in the basic write VTK output files, which usually consist of VTU and VTB, and VTB is for particles and VTU is for cell or for the fluid cells. So usually it's enabled, so we will enable it, and then we will go to the VTK option, and then in the VTK option we have regions, and we only have a region that is called background, which is our frame. But what we want to see in the output, not the cell data for the moment. For example, for the hidden collision, two particles colliding, we want to check for particle data. So it's alright, you choose particle data and you choose background, which is the only region that we have, and then click OK. We don't need this because we already have one, so I'll delete it. And then we have this, and then you can enter the file name, which will appear in the case folder, and here is the write interval. For example, how many times you want the program to write the output files, after what time interval. And as you decrease this, basically you get more frames, so you get a better resolution for your video. So for now I made it e to the -4, 1e to the -4, which stands for 0.0001, and then the start time is 0 and stop time is 0.1. I like to set the stop time like equal to the stop time of the whole program in order to write intervals for the whole simulation. And then here are the variables that you want to include in the output. For example, I included the collision force, the coordination number, the global ID, the overlap statistics, and the transition of velocity, for example. Some other variables you may need in other situations, but that's what we have for the moment. And that's how we set up the output. And now, for example, also if you want, in other cases, in this head of collision case, it's only two particles colliding. But for example, in fluidized bed case, if you also want to produce a cell data for the pressure or the velocity of the gas itself or the fluid itself, then you have to go for cell data. Okay, and then you will have something like a pressure, density, velocity vector, but we don't have any fluid here. We're just dealing here with two particles colliding, so we don't need this at the moment. So we go to run, and then we start running. Okay, something may happen like this, and you click on true because it's restricting the program to only execute the mesh. Now it's runnable. And here is the message. Actually, if you go to the case file, to particles, you will find that the particle data started to be written with the name you given to it. Particles VTB, particles 1 VTB, particles 2 VTB, and etc, etc. So these are the collection of time steps that holds inside of it all the data relevant to the particles, collision force, etc, etc, particle phase ID, and as you know. And then we go to Paraview. And then we open. We have this particles VTB group. So we go for this and we click OK. And there is the very interesting part. We have all the variables that you have chosen: collision force, diameter, maximum overlap, particle ID, etc. Then you click apply. But we don't see anything happening here because actually the particles are too small to be shown in the screen. That's why we use something called glyph. And then as glyph, we gotta use sphere because our particles are basically spheres. And theta resolution and phi resolution are something relevant to the resolution of the view itself, as we will see. But for example, we must scale these particles by a specific factor in order to be able to see them. For example, if I click one here, the scale factor, and I click apply, then we started to see the particles. And you see that the spheres has relatively low resolution because of these non-uniform shape of the sphere. Then we go for theta resolution, jump to 50 for example, and phi resolution, and then we click apply, and then what we get is actually a very high resolution of spheres. And then it's enough for now to choose only the diameter. If we run the simulation, that's what we get exactly. Also to see the fluid cell background, which basically is not necessary in this case but would be necessary in other cases, you click open and you go to for VTU